Hello, so my name is Radovan Polanský. I'm from TCP, Technology Center Písek, and I pleasure to introduce our new solution from TCP. Technology Center Písek is focused on data center business. We build the private cloud platforms. We provide private solution for large customers, and our solutions are robust, flexible, and ready to use in big production from data center environment. So today we show you our new IoT platform, and our IoT platform is same. And I'm glad to see our new IoT team here today, and so it's all because I'm sure that the live presentation is the best way to inform us about our solution. So let me introduce my colleague Jan Pokorný, and he start our presentation. Thank you very much and enjoy our solution.
Thank you for the word, and let's start. Good morning, ladies and gentlemen, and I would like to talk about more in detail about our IoT platform. We are IoT team, what Radovan said in the TCP, and we building the smart city platform mostly based on open source technologies. We have a unique solution from data collection to the cloud services. It means that we have some cooperation, or we cooperate with Tesla on the sensor development. Also, we have gateways and the cloud infrastructure. And I would like to start with the environment module. This model, what I said, is developed with the cooperation of with Tesla, and it's based on IQRF communication. It's outdoor station, and it's possible to measure by this sensor almost 20 quantities. The quantities I'm going to describe at the end of the presentation above the real demo. The outdoor station is also protected by water, of course. It has battery, and during the night when the light is switched on, the battery is charged by the normal power supply. Okay, let's go to the IoT gateway. This is, you can see on the picture, the concept of the gateway. It's split into two parts, let's say, application part and the core stack. Of course, we are running our different platforms because we are trying to be a multi-platform, and the gateway should be the multi-platform and multi-operation system, so working. So we can run on the Raspberry Pi, Ion gateway, for example, as you can see here on the table, and I will talk about at the end of the presentation in demo more. Of course, Intel gateway or even the PC. The supported operation systems are Raspbian, Ubuntu, or Windows IO. And let's go to the application stack. We choose the Node-RED because right now Node-RED is a really good tool based on the flow programming nodes. It has perfect web-based user interface, and of course the main advantage is that the program or the application can touch to the hardware directly. The nodes can access to the hardware, for example, for Modbus, and get data from it. So that's the open source software, and right now we are going to Temujin. It's our proprietary software. It has various device integration, and the main advantage is IQRF network management. It can get data from the IQRF network, translate in our protocol. We're using the JSON and the SendML format. It's a sensoric markup language, and send via MQTT to our cloud. Of course, it's necessary to configure that program, and for that we have a web-based administrator. Configuration. The other part is a configuration. We need to configure not only the Temujin or Node-RED, but also the IP address, the mask of network and DNS servers and so on, so on. So we have the web configuration interface, and other monitoring system is or updating system is a Salt. Salt stack is used mostly for the software updates and for direct control of the gateway. Other is a remote management, because we need to remotely control the gateway through the cloud. So it's not necessary. It's not good to have some only local web configuration. So it's paired with the cloud configuration, of course. And other most important part is the MQTT broker. MQTT broker is used for such as a communication hub between the applications. So our program, Temujin, can communicate via the MQTT broker with the Node-RED. Node-RED can do something with the data and send to the cloud or to the MQTT back. MQTT broker Mosquito can send data to the cloud, of course, and has buffering in case that the connection will be lost, for example, or would be lost. I forgot, sorry. Other important thing that the MQTT broker locally on the web, on the gateway can communicate with other gateway. So it's for building some network of gateways. And only one gateway can communicate to the cloud, for example. Okay, this is some overview, and right now I would like to pass a word to my colleague, and he will continue with the IoT cloud and its infrastructure.
Good morning. My name is Jirka, and I would like to describe you our cloud infrastructure. As Honza said, we have IoT gateway, which communicates with our cloud using MQTT protocol. And it's not only our gateway. Every device, every other gateway which supports MQTT protocol can communicate with our cloud. First thing is that data are coming to our MQTT broker, which is the first part of our solution, and receive these messages. MQTT broker also performs authentication and isolation. I will tell you more about it later. Then the message is going to our RabbitMQ cluster, which provides internal communication and distribution, and also it's a durable layer. Then the message goes to the parser, which parses usable data from MQTT message, because we support multiple formats. And then these metrics are saved to the databases. We wanted our infrastructure to be solid, so we have chosen proven open source technologies. Our cloud also is scalable, is high available. This is a really important things of true solid infrastructure. And for the purpose, we are using Kubernetes, which is the orchestration tool for Docker containers. So we are containerizing. We're using Gluster file system as a storage backend, and we provision and manage this entire infrastructure using Salt Stack. As I said, the first part of our infrastructure is MQTT broker, which is a proprietary software written in Node.js. It's just like any other MQTT broker, so it supports subscribe, publish, retain messages, and so on. This broker also provides authentication of clients, which is the most important part of this software. And main reason why we write this software on our own is that it supports multi-tenant isolation, which means that on this one solution, you can have many clients working in the same environment and also isolated. So it means that these clients cannot interfere, cannot see others' messages. Next part is RabbitMQ cluster. RabbitMQ cluster received the raw message from connector and wrote it internally to the rest of our systems. RabbitMQ has a multi-protocol support. And it's a really solid backend to our solution because it's high available, it's also scalable and durable. The really important feature is its durability, because in case of failure, the messages, your messages, our client messages are never lost. They wait in RabbitMQ to be processed later. So next part is message processing and data storing. For that purpose, we created our own parser. Parser gets the raw message, which comes in MQTT to our cloud, and tries to parse its contents. It's because we support multiple formats. Of course, classic metrics such as numbers, integers, floats, also strings, but we also support JSON and SNML. So when a message is in JSON format, it's automatically parsed and normalized to some standard format in our infrastructure. Another main feature of parser is that it's add metadata to your metrics. So as a customer, you can describe your topics with metadata, and parser puts these metadata to the metrics before it stores there in database. So this spec messages with metadata are then stored in database storages. Currently, we are using InfluxDB and Elasticsearch. Good feature of this parser is also that we can choose different databases based on contents. So for numeric metrics, we can use InfluxDB. If your messages are structured data, we can choose Elasticsearch. Also, these databases has a great support for data analysis. Solid infrastructure needs solid monitoring. For that purpose, we've chosen Prometheus, which is an open source monitoring system. It also acts as a time series database. And this solution is really simple. It just scrapes metrics from remote systems. Prometheus has a native support for operating system monitoring, for Kubernetes cluster, and it's also really simple to integrate metrics to your own application. So we can monitor our connector or our parser with Prometheus too. The last and very important part of a cloud solution is data visualization. We are using Grafana, which is also open source project. And Grafana is a really great solution because it can visualize your data in a really user-intuitive way. And it's really very customizable. So as a user or as an administrator, you can create your own dashboards. You can create your own charts, such as linear charts, gauges, and so on. So this is really user-friendly solution, and also it supports alerting, so you can set up alert on your data when some threshold is matched. So now I would like to invite my colleague Honza back, and he will show you a live demo of our solution.
Okay, during my colleague switching the monitor to the Grafana, I would like to show you the Tesla sensor. You can see here, and this sensor is running right now. Data are collected by this ION gateway, and yeah, we see that. I take the laser. Okay, so there you can see the graphs. With the data which are measuring right now, there are gases like NO2, ozone, CO, NO2, the concentration of the gases are not precise right now because the sensor was started up this morning, and a couple hours it's necessary to stabilize the value of the sensors, gas sensors. But what is working? It's a UV light. We don't see the light, the visible light, because we have the range 60,000. Sorry for that. There is much less light right now. Of course, we see the pressure, temperature, and if you can scroll down, please, a bit. Relative humidity. There are, I think, on values what can we measure, but we can measure also dust concentration in air. It's really important for the smart cities because they need it, then they want it, because there's some kind, or how to say that, dust is important because it takes some information about the illness or something like that. I think that's it. You can see that it's really working, and thank you for your attention. If you have some question for us, you can find it near to our stand, and we appreciate if you have some question for us, and we will answer it. Thank you.